morning. In our previous videos, we've looked at adding, subtracting, and multiplication using matrices. And in this video, we're going to look at how you form the inverse of a square matrix. So we're going to consider these four examples today. The first two are 2 by 2 matrices, and these last two are 3 by 3 matrices. So we'll begin with forming the inverse of number 1 here. So we're going to use something called the Gauss-Jordan method. And so to begin with, we set up the identity matrix to the right of the given matrix. Okay, so like this. Here is the given matrix here. And to the right of it, we include an identity matrix. So to form this, you must make it the same size as the original. And all you have to do is put ones on the principal diagonal and zeros everywhere else. So just like this. And now we're going to use the Gauss-Jordan method to transpose this. What we're going to have when we're done is the identity matrix on the left side, and on the right side will be the inverse of this original matrix. Okay, how do we do this? Well, the first thing we want to do is make sure we get a 1 in the top left corner here, okay? Because we're trying to form this matrix, remember. So we want a 1 in the top left corner. How can we do that? We can take the first row and multiply it by -1/2. Or you could also think of it as taking that first row and dividing it by -2. We will not change the second row. Okay, so that would look like this. If we divide all of these numbers by -2, they will become these new numbers. You'll notice we did not change that second row. All right, next, now that we have the desired 1 here, the next step is to get a 0 under it. Okay, 0 under it here. It's like the method of elimination that you reviewed for solving 2 by 2 linear systems. How could we get a 0 here? Well, if we multiplied the first row by -3 first, and then added it to the second row, we would get 0 here. Because -3 times 1, of course, is -3. -3 added to 3 would give us 0 here. So that's the plan. We're going to change row 2. We're not going to change row 1. We're going to change row 2. We're going to replace it with -3 times row 1 added to row 2. Okay, so look. The first row remains unchanged. And now we do this. -3 times 1 plus 3 is 0. -3 times -3 is 9. Plus -4 is 5. -3 times -1/2 is 3/2. Plus 0 is 3/2. Lastly, -3 times 0 is 0. Plus 1 is 1. So that's what we get in the bottom row if we execute this plan here. Okay, now we've got the first column set up appropriately. We have to change the second column so that it looks like this, remember. First, get a 1 here. How do we get a 1 here? We divide this row by 5, or we multiply this row by 1/5. Okay, so this is the plan we're going to execute. We're going to change the second row only. So you should see that I did not change that top row. And now we're doing 1/5 times the second row. So 1/5 times 0, 1/5 times 5, 1/5 times 3 halves, and 1/5 times 1, like that. Okay, last thing we need to change, of course, we need a 0 here. How can I get 0 here? Well, what if I multiply this by 3 and add it to this? That will give me a 0 here. So that's the plan we're going to execute. We're going to take 3 times row 2 and add row 1. So the second row will stay exactly as it is. Don't change the second row. And now here we go. We're going to do 3 times 1. No, sorry. We're doing 3 times row 2 and adding row 1. 3 times 0 is 0. Plus 1 is 1. 3 times 1 is 3. Add -3 and you get 0. 3 times 3/10 is 9/10. Take 9/10 and add -1/2 and you will get 2/5. And finally, 3 times 1/5 is 3/5. Add 0 and you will get 3/5. Okay, so this can be a little tricky at first, which is why we're going to do 4 examples in total together. But the point here is, once you have the identity matrix now on the left, what you have on the right is the inverse of the original matrix. So we can say here that A inverse is equal to 2/5, 3/10, 3/5, 1/5. Just like that. Okay, shall we try a second one? So once again, we're going to do a 2x2 matrix. We are going to work out its inverse. So let's get this set up. Okay, so we have the desired setup. We've got the original on the left, the identity matrix on the right. Remember the order. First get a 1 here, then a 0 under it. Then get a 1 here, and then a 0 above it. So that is going to govern how we proceed here. Okay, first, getting a 1 here means multiplying this first row by -1/2. So the plan is outlined here. Second row stays the same. Okay, so second row stays the same, and I did -1/2 all of these numbers, and I got these new numbers after multiplying them all by -1/2. Okay, secondly, we want a 0 here. How can we get a 0 here? If I triple this and add it to this. So we are not going to touch the first row. You're going to see in a moment the first row remains the same. The second row is replaced with 3 times the first row plus the second row. Okay, so the first row stayed the same. And now let's do this operation. 3R1 plus R2, like this. 3 times 1 is 3. Add it to -3 and get 0. 3 times -3/2 is -9/2. Add it to 5 and you will get 1/2. 3 times -1/2 is -3/2. Add that to 0 to get -3/2. And 3 times 0 is 0. Add it to 1 and you will get 1. At that point, we have a perfect first column. Next, a 1 here is required. How can we get a 1 here? By doubling that second row. So, first row stays the same. The second row is doubled. 0, 1, -3, and 2. Like that. Lastly, the requirement is for a 0 here. How can we get a 0 here? Well, let's multiply this by 3/2 and add it to this. So that means 3/2 of row 2 plus row 1. Second row will stay the same. There it is, staying the same. And now we do this operation to figure out the new top row. So 3/2 R2 plus R1. So 3/2 times 0 is 0. Plus 1 is 1. 3/2 times 1 is 3/2. Plus -3/2 is 0. 3/2 times -3 is -9/2. Plus -1/2 is -5. And lastly, 3/2 times 2 is 2. Plus 0 is, sorry, I need to say that again. 3/2 times 2 is 3. 3 plus 0 is 3. Just like that, okay? Okay, so now we've got the identity matrix on the left, which means that on the right we have the inverse of the original matrix. So if the original matrix was named A, then this 2 by 2 matrix is named A inverse. Okay? Okay, we're going to try now a couple of 3 by 3 examples. So these are even a little bit more involved. So let's take a look at example 3. Okay, let me cover up some of it. So the original goes on the left. We make the identity matrix on the right. Now this is a 3 by 3 identity matrix. 1's in the principal diagonal and 0's everywhere else. Okay, the process is as follows. First, get a 1 here, then 0's below it. Okay, so we're setting up perfectly this. So first a 1 here, then 0's before it, below it. So how do we get a 1 here? We divide this whole first row by -2, or we multiply the whole first row by -1/2. That would look like this. So the second and third rows didn't change. We did -1/2 times the first row. Okay, we already have a 0 here, which is great. So now we're going to get a 0 right here. How can we do that? Well, we can multiply this by -4 and add it to this. So that's the plan. -4 times R1 will be added to R3, and that will replace this bottom row. So you can see the first 2 rows stayed exactly the same. And now we do this. -4 times 1 plus 4 is 0. -4 times -4 times -3 is 12, plus -7 is 5. -4 times -1/2 is 2, plus 3 is 5. -4 times -1/2 is 2, plus 0 is 2. -4 times 0 is 0, plus 0 is 0. And -4 times 0 is 0, plus 1 is 1. So we get this set up next. Okay, once the first column is set up, we move to column 2. establish the 1 first. So we need a 1 right here. So divide that whole divide that whole row by 3. So the only changing row there is the middle one. We divided all numbers there by 3. Okay, next we need a 0 here and a 0 here. We can do these operations both. So how would I get a 0 here? I could do 3 times row 2 added to row 1. So that plan is listed here. How could I get a 0 here? I could do -5 times row 2 and add it to row 3. So in this next step, only the middle column will be unchanged like that. So the middle column has stayed the same. And now I would execute both of those plans. And in doing so, I would get this new first row and this new last row. Okay, now I've got the first 2 columns established perfectly. So the next thing we need to do is work on the last column. First, we would get a 1 right here. How can we do that? We do 1/10 of R3. So the first 2 rows stay the same. That last row is divided by 10. And that would give us these numbers now in that bottom row. Lastly, we need zeros here and here. Let's do these one at a time. How can I get a 0 here? I can simply add rows 2 and 3. So the bottom row remains unchanged. The second row would be replaced with the sum of R2 and R3. How can I get a 0 here? Well, I can multiply row 3 by 7/2 and then add it to row 1. So that's the plan of action listed. And once I carry out those 2 operations, leaving the bottom row alone, I end up with this. The identity matrix is on the left, so that means that on the right now is the inverse. Okay, so that matrix right there is the inverse of the original. Okay, let's do one more 3 by 3 together. I won't make you guys do a 4 by 4. That sounds kind of dreadful to me as well. Okay, so here we go. We're gonna do one more example of a 3 by 3. Here it is. Let's start by setting it up properly. Okay, so there we go. We've got the 3 by 3 identity matrix on the right. All right, we've already got that 1 requirement in the top left. So what we need is a 0 here and a 0 here. Okay, so what is the plan? In order to get a 0 here, I can do -3 times row 1 plus row 2. How can I get a 0 here? I can simply add row 1 with row 3. Okay, so these 2 rows are now replaced by carrying out those operations. First row remained the same. Okay. First column is now perfect. Move on to the second one. Now look, in that second one, I've already got the 1 that would be required next. Then we would check to make sure we have 0 here and 0 here. Well, that one's already done for us. So we need only to confirm a 0 here. How can we get a 0 here? Well, what if we do -2 times row 2 and add it to row 1? So that's the plan. The first row will be replaced with this combination. So second row, third row, stay the same. Maybe I'll go through that one with you just to make sure, okay? So we're changing these numbers by executing this plan. So it would be like this. -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 2 is 0. -2 times -2 is 4, plus -1 is 3. -2 times -3 is 6, plus 1 is 7. -2 times 1 is -2, plus 0 is -2. And lastly, -2 times 0 is 0, plus 0 is 0. Okay, first two columns are perfect. Let's look at the last column. First, get the 1 in the correct spot right here. How do we do that? By multiplying this whole bottom row by -1. That's an easy one. First two rows stay the same. Multiply here through by -1. We now have this bottom row. Lastly, we need the 2 zeros here so we can adjust both rows. How can we get a 0 here? Let's do 2 times row 3 plus row 2. 2 times row 3 plus row 2. How can I get a 0 here? Let's do -3 times row 3 plus row 1, like this. Okay, so in this last step, the bottom row stays the same and we have to perform both of those operations. Maybe I'll go through them with you since they are the last operations here. Okay, should we do this one first? So changing this row to this row by following these steps is done like this. 2 times row 3 plus row 2. So 2 times 0 plus 0 is 0. 2 times 0 plus 1 is 1. 2 times 1 plus -2 is 0. 2 times -1 plus -3 is -5. 2 times 0 plus 1 is 1. 2 times -1 plus 0 is -2. So that was adjusting the middle row. And finally, let's change the top row. So the top row will become this by applying this procedure. So -3 times R3 should be added to R1. So -3 times 0 plus 1 is 1. -3 times 0 plus 0 is 0. -3 times 1 plus 3 is 0. -3 times -1 plus 7 is 10. -3 times 0 plus -2 is -2. And finally, -3 times -1 plus 0 is 3. So what do we have? We have the identity matrix on the left and the inverse of the original matrix on the right. So right here would be A inverse. Okay? All right. One final note for the lesson today is that if you take a matrix and multiply it by its inverse, you will get the identity matrix back. So it's kind of a way of checking that you have done your inverse correctly. If you take the time to then multiply the inverse and original together, you should get the identity matrix here. Okay, so that was just really a brief look at matrices. Again, all we have learned to do so far in the course is adding, subtracting, and multiplying, as well as finding the inverse of a 2 by 2 or 3 by 3 matrix. And really that's all we have time to cover, because the rest of this course will be a look at differential calculus and its applications. So again, I will be posting suggested problems from 16.1, 16.2, and 16.3 of your textbook so that you can practice these operations with matrices. And the first quiz of this course concerns itself with matrices, and you should complete that using MyMathLab. Okay, thanks very much, and I hope you have a great day.